Bismillahirrahmanirrahim. The last part we talked about logarithmic functions, in which we discuss how to sketch the logarithmic function and how to evaluate some logarithm, and also how to convert the exponential form to logarithmic form or the logarithmic form to exponential form. In this section, this 4.4, we are going to speak about the logarithm and logarithmic scales, in which that we are going to discuss some properties for the logarithms. Suppose that we have three numbers b, m, and n are real numbers where b is not equal to 1. Then we have different properties for the logarithm. Start with the first one, b1. First property we call the product rule. The product rule or the product property. If we have log the base b of m multiplied by n, then this can be written as log b of m plus log b of n. So the product is, or can be written as, sum of two logarithms, logarithm of m plus logarithm of n. The second property, b2, the quotient rule. Or quotient property. They said that if we have division of two quantities, if it is logarithm of p of m divided by n, then this can be written as logarithm of p of m minus logarithm with the base b of n. So the product will give me plus, and the quotient will give me minus. Third one, if we have power property, P3, just state that logarithm of b of m to power n can be written as n multiplied by logarithm of m with base b. Meaning this n is written down as a product. It is n multiplied by logarithm of m with base b. Fourth one, we call the one-to-one property. And that if we have equality of two logarithms, this will be 4, 1 to 1 property. We say that if I have log base b of m equal to log base b of n, this means m and n are equal. So this is the one-to-one property of logarithm. If we have equality between or of two logarithms with the same basis, then the quantities m and n must be equal. So these are the four properties for the logarithm. We have product, we have quotient, we have power, and we have one-to-one property. These properties are used to expand the logarithm sometimes or to write it in a compact form. And this is very useful to later on to solve logarithmic equations. For example, see, I want to expand the given logarithm. Number one. So for that, we have logarithm of 2 base 2 of x times y times z. And to expand it means write it as summation of logarithm or subtraction, depending on whether that we have multiplication or we have division or power. This is x multiplied by y by z. To expand it, we are going to write it as logarithm with base 2 of x. Since we have products, this will convert to b plus using the first property, logarithm 2 of y plus logarithm 2 of z. So we expand the given logarithm into 3 logarithms. Number 2, suppose that we have ln of x divided by square root of y. And I want to expand this one. And as we stated before, ln is natural logarithm. The base is e. With this in mind that ln, it means log with the base e, where e is approximated by 2.71. So ln can be written now as ln of x divided by y to power 1/2. Square root is y to power 1/2, which can be written as ln of x minus ln of y to power 1/2. This can be written as ln of x minus, since I have power there, this power will be written as product. I will have 1/2 ln of y. So we expanded the given logarithm. One more, number 3. If I have ln of, say, square root of x divided by, not x, y square z to power 1. And we need to expand it. This can be written as ln square root of x minus ln y square minus ln of z. Anything in the denominator will be written as negative or subtraction. So this is ln of square root of x minus ln y square minus ln of z, which is equal to square root of x, it is 1/2, so I can write it as 1/2 ln x minus 2 ln of y minus ln of z. So again, if we have product in the numerator, we are going to write plus or addition between two logarithms. If we have product in the denominator, then it is minus. So we have to be careful about this sign, because if we just want to make it more clear, this is ln of x to the power 1/2 minus ln of y square z. Because of this ln, if we expand the second one, I will have ln of y square plus ln z. But this minus outside, if I multiply by negative, or I'm sorry, by positive, I will have this negative sign. So you can say in general, if you have any quantity in the denominator and if you want to expand it, write it with the negative sign. It is minus ln or minus log of that quantity. Number 4. With that we have log of b, make a general, x square root of y divided by z to power 3. And I want to expand it. This is equal to log b x square plus log b y to power 1/2 minus log b of z to power 3, which is equal to, now using the power property, I will have 2 logarithm b of x plus 1/2 log b of y minus 3 log b of z. So this is the idea of using the properties to expand a logarithmic expression. Now, if we reverse the process, suppose that you are given expanded form and we need to write it as a single logarithm. This will be the second type of the questions. Let's say that we have, I need to write each expression as a single logarithm with coefficient 1. So we need to write each expression for the following as a single logarithm with coefficient 1. Number 1. So that I have 3 log base 2 of t minus 1/3 log base 2 of x plus 4 log of y with base 2. And you have to be careful about this one. We must have the same basis for the logarithm so that I can combine them. If we have different bases, we cannot write them as a single logarithm. So the basis must be the same. Now to write this as one logarithm, let's do it in 2 steps. This is equal to. Third one, this is, I'm going to use the power property. So I can write it as log base 2 of t to power 3 minus, this is power, log base 2 of x to power 1/3 plus 4, this is also power, this is power, it will be log base 2 of y to power 4. Now, any positive means a product and any negative means division. So this will be written as single logarithm with coefficient 1 of t to power 3. This is negative, it means this quantity will be down. X to power 1/3. This is positive, means will be up. Y to power 4. So this is the idea of writing expression as a single logarithm. Single logarithm means we will have only one logarithmic notation, which is only one log. And the quantity will be there as a product or division. Take another one. Number 2. So for that I have 2 log of base 6 x plus log 6y square minus log 6x plus 2. It's the same idea. So I can do it in 2 steps. Just to make it clear, this will be equal to. What is inside the bracket? We'll start with this bracket. I have 2. Since we have a plus, I can write it as a product, will be single product, single logarithm. So this is a logarithm of 6. Since we have a plus, it will be x times y squared minus log 6 of x plus 2. Now, using the power property, this is equal to, this is power now. I have log of 6 x y squared all to power 2. I'm using this as power. This log of 6 or of xy squared with base 6 to all to power 2 minus log 6 of x plus 2, which is equal to log, just one logarithm, single logarithm, six of, since I have minus there, then it means we have division. It is x y square all to power 2 divided by x plus 2. So this is how to write expression with a single logarithm with coefficient 1. One more example, number 3. For that we have log of b or base b of x squared plus 7x plus 12 minus 2 log of x plus 4. And I want to write it as a single logarithm. It can be written as log of b. I forgot to write the base b there. Of x squared plus 7x plus 12 minus log x plus 4 to power 2. Now, since we have negative, this is equal to b. It is division. I will have x squared plus 7x plus 12 divided by x plus 4 to power 2. So we wrote it as a single logarithm. It can be simplified if you can factor the numerator, which is x plus 3 multiplied by x plus 4. This in case we need to simplify it. Up to now it's okay. But if we need to simplify it, this is just extra step. Sometimes I want to simplify. I will have, for the numerator, I have x plus 3 divided by x plus 4 divided by x plus 4 to power 2. This is just in case we need to simplify it more. But if the question only just write it as a single logarithm, then up to this step is okay. But if I want to simplify it, I will take the common factor. Then this can be written as log base b of x plus 3 divided by x plus 4. And that's it. Now we wrote this expression as single logarithm with coefficient 1. When we say the coefficient 1 means there's no number except 1 as a coefficient for the logarithm. There's only 1. That's what we need to write.